All right, so we're going to, didn't know there were sound effects, sorry. We're going to be talking about probability. We started this yesterday, and we're just going to kind of continue along those lines. The first part of this presentation sort of reviews what we've already done, or what we talked about yesterday, and then we'll go into the new stuff. So here we go. Probability. We talked about this yesterday. It's a measure of how likely an event is to occur. For example, today there's a 60% chance of rain. The odds of winning the lottery are 1,000,000 to 1. And then it says, what are some examples you can think of? So let's just keep going. We already did that a little bit. All right. Probabilities are written as fractions from 0 to 1. We did the number line activity where you put 0, 1/2, 1/4, 3/4, and so on. You could also write any fraction as a decimal, so they're decimals, and you can do them as percents too. If an event is certain to happen, then the probability of the event is 1 or 100%. So 100% chance of rain means that it should be certain to rain. You could say that about flipping a coin. It is certain that you'll get either heads or tails. You will get one of those two when you flip it, so that's certain. But if it will never happen, it's 0%. So the probability of rolling a die and getting an 8, if it's a 6-sided die, is impossible. So that's a 0% chance. Most things, though, are in between those two things. That most things are maybe 50% chance. 50% chance of getting a heads on a coin. Or maybe they're almost 100% chance. Like there's almost 100% chance that I'll wake up in the morning and go to work. You know, something could happen where it didn't happen, but it's pretty close, 90-something% chance. And this is that number line, like the activity that you did yesterday.
Me?
When a meteorologist states that the chance of rain is 50%, they're saying basically that it could rain, could not. It's pretty much an equal chance. You know, half the days that they say that it should rain, the other half. So out of 4 days, if they say 50% chance of rain, that means about 2 of those days it should rain. Now, that doesn't, it's not perfect. Could be 3 days, it could be no days, but that's what they're thinking. It's a good guess. Chance of rain is 80%, then we're pretty sure it's going to rain. You're probably going to want to bring an umbrella that day. 20% means it may rain, but probably not. Keep going. I'm just going to skip through this because we talked about that. All right, so this is where we get into the new stuff that's really important. So pay attention here. The probability of an event is written. And notice, let me see if I can use my mouse here to point. Notice the way they do it is the probability, and then they put whatever the event you're talking about here. So we'll look at some examples, but if it were heads, you would say probability, and you would put heads here, probability of heads. So basically, you put the number of ways the event can occur over the total things that could happen, the total number of outcomes. The outcomes is just what could happen. So let's see if we have some examples here. So the number of ways it can occur over outcomes. Outcome is a possible result, so anything that could happen is called an outcome. So in rolling a number cube, or a die, the possible outcomes are 1, 2, 3, 4, 5, 6. So let's count. 1, 2, 3, 4, 6 different possible outcomes. An event is a specific result of a probability experiment. So that's basically, if you flip a coin and get heads, the event was that you got heads. If you roll a number cube and get a 3, that was the event. The event was getting a 3. So when rolling a number cube, the event of rolling an even number is 3. You could roll a 2, a 4, or a 6. Those are all even. So what is the probability of getting heads when flipping a coin? Let's look at that. So notice in parentheses they put heads because that's what you're finding the probability of. So the probability of getting heads, well, how many heads are on a coin? Just 1. So we have a 1 down here. Over how many sides to a coin? There are 2. So the probability is 1 out of 2, which is 0.5 or 50%. So there's a 50% chance of getting heads. Let's look at these examples. All right. Let's see if no, they didn't. Oh, cancel that. Sorry about that. Let's go back to that last slide. And where's the button? I don't see it on here. Okay, let's just go back through. Sorry, you're going to hear a bunch of All right, so here we are again on these. So now we're going to find the probability of these things together. So what is the probability that the spinner will stop on part A? So if we look here, the probability of A, I'm just going to pull up a Word document here. Oops, let's not pull up that one. Let's get a different one instead. Get a blank one here. So the way we write this is, so since we're finding A, we're going to put capital P A, because we're finding the probability of A, equals, now let's look. We want to put the total number of favorable events, basically how many A's are there over the total possible. So it looks like there's only one A, so I'm going to put a 1 as my numerator. So you can see that there. Let me make this just a little bit bigger. There you go. All right. Now for our denominator, we need to count the total possible. So 1, 2, 3, 4 parts of this spinner. So there are 4 possible outcomes, so 4 is our denominator. So 1 out of 4 chance of getting A. I'm just going to do it this way. There, 1 out of 4 chance, which is, let's see, 0.25, which equals 25% chance of getting A. Let's look at the next one. What is the probability that the spinner will stop on A, an even number? So the first thing we're going to do is probability of even. So let's look at that first. So on here, remember, the numerator is the number of favorable outcomes, the number of things you want to happen, the events. So how many even numbers are here? Let's see, just 1. So our numerator is 1. The denominator is the total number of things that could happen, the possible outcomes. So in this case, we have 1, 2, 3 numbers. So it's 1 out of 3 chance. So the probability of getting an even number is 1 out of 3. And make that a decimal would be 0.33, which equals 33%. Let's find the probability of odd. I think that's the second one. Probability of an odd number. Well, in this case, we really don't even have to count because we know their odds are all that's left. So if 1 out of 3 is even, then, well, 2 out of 3 must be odd, which is 0.66, which equals 66%. Let's look at the last one here. What is the probability that the spinner will stop in the area marked A? So, it's difficult to judge because I think someone drew this. I don't know if they were going to make them the same size because it looks like A is bigger, which makes this sort of incorrect. We're going to assume that A is the same size because I don't know that I can find the probability otherwise. So we're going to say the probability of A, and we're going to say they're the same size because I can't tell. So there's 1A out of 3, which equals 0.33, which equals 33%. So that's all those probabilities. And then we can describe them. We can say, all right, what's the chance of getting an A? Well, it's just 25%, so that would be unlikely. Which all that means is if we spin the spinner, we'll get B, C, or D more often. But sometimes we'll get an A, so it's unlikely but possible. Same thing here, it's less than a 50% chance, so it's unlikely that we'll get an even number. It's much more likely that it'll be 1 or 3 because more space is taken up with the 1 and 3, but it is possible. Now here's one, 66%. Well, if we're talking about odds, it looks like there are 2 numbers that are odds, so it's really much more likely that we'll get an odd because there are 2 of them versus just 1 even. So we'll call that likely. And notice none of these things are certain or impossible. They're unlikely or likely. And this would also be unlikely. It's the same as the one above it. So that gets us, well, actually we do have one more here. Let's just look at this one. Lawrence is the captain of his trap team. The team is deciding on a color, and all 8 members wrote their choices down on equal size cards. If Lawrence picks one card at random, what is the probability that he will pick blue? So for this problem, what we're going to do, put in parentheses, is the word blue, because that's what we're finding the probability of. So remember, just like before, we have to count the favorable outcomes over the possible. So let's look. There's 1, 2, 3, 3 blues. So 3 is our numerator. Out of 1, 2, 3, 4, 5, 6, 8 cards, so 3 out of 8 times we should get blue. And I think that's enough for this. We'll just try to practice it after you've watched this video.